Hello everyone! In this video, we're going to learn about the work and power. Let's start. On your screen, there are two persons. The first is trying to move the wall, and the second is trying to move the trolley. A force is applied in both cases, regardless if it is causing or does not causing a displacement, because force is a push or a pull. But since the force exerted on the trolley caused the displacement, the second person did work, while the first person who applied the force on the wall, he didn't do work because his force didn't cause any displacement. Based on this activity, are you able to define work? Work is transfer of energy by means of a force, and it is the product of the force parallel to the displacement and the covered distance. In order to do work, a force must cause a displacement, and this displacement must be in the same direction of the force. In order to understand this concept, let's read these examples. In which direction the force is applied? The man is pushing the box horizontally. In which direction the box is displaced? The box is displaced horizontally as well. Therefore, the man did work because his force caused the displacement and his work is equal product to the horizontal force and the horizontal displacement. Now look at this rabbit. What is the direction of the force applied on the basket? It's clear that the direction is vertically upward. In which direction does the basket move? The basket is moving forward. Then, the force and the displacement are perpendicular to each other. Accordingly, the rabbit is not doing work by holding the basket. Look at this man. He's lifting a heavy box. In which direction the force is applied? If your answer, the direction of the force, is upward, then you are correct. Now, in which direction is the box moved? It's clear that the box is moving upward. Then, both the direction of the force and the displacement are parallel to each other, and therefore the man did work. Now, as everything is clear about work, let's introduce the power. What is power? Power is the rate at which work is done. It's calculated by applying the formula P equals work over time, and it's measured in watt. Where work is always calculated in joules, as we know, and time is calculated in seconds. Let's take this example. What is the amount of water applied by this man? It's clear from the formula that power is equal to work over time. So let's calculate the work first. The picture shows that a force of 12 Newton is applied on the box and to move it to a distance of 5 meters. So let's start first by writing the formula W equals F multiplied by D. By replacing each term by its value, W equals 12 multiplied by 5, and then the work is equal to 60 joules. Now, let's replace the work by its value in the formula P equals W over T. So, power equals 60 joules over 3 seconds, and then the power will be equal to 20. What is the unit of the power? If your answer is watt, then you are correct. Therefore, the power applied by the man is 20 watt. Let's investigate the effect of time needed to do the work on the amount of power. Do you think that power needs more time or less time? Let's investigate this. Let's first calculate the work. We always start by writing the formula W equal F multiplied by D. Then we replaced each term by its value. So in the place of F, I write 50, and in the place of D, I write 5. Accordingly, W equals 50 multiplied by 5, and then W equals 250 joules. Now, let's calculate the power. In case A, when the time needed is 5 seconds, and in case B, when the time needed is 10 seconds, and then we'll compare. Let's start with case A. We always start the calculation by writing down the formula of the power. Power equals work over time. Then we replace each term by its value. So, replace the work by 250 and the time by 5 and then divide to get the power. The answer is 50 watts. Now, let's calculate the power when more time it takes to do the work. The time in this case is extended to 10 seconds. Apply the formula power equal work over time. Then power equals 250 over 10, and then the power is equal to 25 watt. As a result, in case A, the amount of power is larger than the amount of power in case B. Therefore, as the time gets larger, the amount of power decreases.